Okay, students, here we are working with our Earth's interior diagram. You should have this already printed out. If you don't, that's okay. You can make a quick sketch and just put this video on pause while you do this. So you want this basic pie diagram with the different layers, and of course go ahead and try to label it as we have now. So we're going to start over here on this side. Note that this heading is chemical composition of different parts of Earth's interior. We'll be looking at the main elements that are present within each one of these three zones: the core, mantle, and crust. We'll start down here with the core. As you know, according to our discussion of planetary differentiation, once Earth was molten throughout, heavier elements were able to settle all the way to Earth's core. As those heavier elements sank, they displaced lighter elements towards the exterior. And this is expressed real clearly with the elements. For example, within the core, the two major elements are iron, Fe is the atomic symbol, and the other is nickel. So these are what you will find next time you go to the core. It's thousands of miles deep. It'll be a while. Now, as we come toward the exterior, it's very different. Here we get into lots of much lighter elements. The dominant components of both the mantle and the crust: oxygen, number one, so O. Coming in second place is silicon. Both are very abundant and they like to bond to each other. So what we see is that the crust and the mantle are composed of minerals rich in oxygen and silicon. Within the mantle, you'll also get quite a bit of calcium, lots of magnesium, and of course iron is going to be present throughout the planet. It's really abundant. Then as we go up to the crust, this is where the lightest of the elements got concentrated. Again, very rich in oxygen, lots of silicon. Then we have an abundance of aluminum, potassium, other ingredients, and of course, iron is present. So this is Earth's interior zoned based on chemical composition. Not too complex. Now, it will get a little more complex as we shift over here to the other side. Here we have layers of Earth's interior based on their physical properties. Do they behave as a solid or a liquid? You need to be aware of two trends. As you go from Earth's surface deeper and deeper underground, what happens within the Earth? Let me extend this arrow down like so, and you can do the same thing on your sheet, is that at Earth's surface, temperature is relatively low, as is pressure. As you go deeper underground, you have the weight of the overlying rocks on top, so the deeper you go, the greater the pressure. And this is a linear relationship. So I'm going to turn this to the right, just like this. I'm going to put over here that pressure increases with increasing depth, and at the same time as we go deeper underground, temperature also increases. And this is a little more complex. But these are two important trends for you to understand about Earth's interior with regard to physical properties. The reason temperature increases is that within the core we have a high concentration of radioactive elements. They're in the process of decaying. As they do so, they release heat. So the closer you go to the core, the hotter it gets. The inner core probably approaches a temperature of about 1,000,000 degrees Fahrenheit, and up here at the surface where we live, average temperature is probably 60 degrees Fahrenheit. So massive difference. So what we want to do is keep these two major factors in mind, and we're going to go deep. We're going to go down to Earth's center. So within the inner core, both pressure and temperature are very, very high. But the effects of pressure override the effects of temperature. We have so much pressure that the atoms are locked together, they're going to behave as a solid. So what we see here is that effects of pressure are greater than the effects of temperature. Even though it's hot enough to melt this iron and nickel core, pressure overrides that. And therefore, the solid core exists. Now, as we go toward Earth's exterior, moving into the outer core, things change a little bit. Pressure is still pretty high, temperature is still very high. So as we go toward the exterior, pressure decreases enough that temperature now has a greater effect. So the effects of temperature are greater than the effects of pressure. The outer core is a liquid. Not too complex. So as we go from the outer core into the mesosphere, this is the main part of the mantle. Meso means middle, sphere, a globe. So this is Middle Earth. Those of you into the Hobbit and those movies, you'll recognize that term, Middle Earth. So this is where they have their fun and games. The mesosphere, the effects of pressure override the effects of temperature. So, solid or liquid, let's see. Pressure holds those atoms together. It's got to behave as a solid. We continue upward, still within the mantle. Here we're in something called the asthenosphere. This is a really unusual portion of Earth's interior through here. What we see here, according to seismic evidence, that is from earthquakes, as that energy moves through, this layer tends to behave a little bit more as a liquid than as a solid, but it's a very, very thick, pasty liquid. So with regard to physical properties, the effects of temperature are just barely greater than the effects of pressure. So that's why we put in the symbol greater than or equal to. So we'll list here that it behaves as a thick liquid. Something much thicker than motor oil, for example, which is a fairly thick liquid. Then we get up to the top, looking at the lithosphere. The lithosphere includes both the very uppermost part of the mantle as well as the crust. We live on top of the lithosphere. You know for a fact that it's solid. Go outside, walk around, you're walking on a solid. So we already know the physical property of the lithosphere. It's solid, therefore the effects of pressure must override the effects of temperature for it to behave as a solid. So, at this stage in our need for knowledge of Earth's interior, these are the key things I want you to be aware of. Keep this diagram handy because we'll come back to it when we discuss plate tectonics and other aspects of Earth's interior. Okay? If you have any questions, of course, feel free to go on the chat or send me an email. We can discuss it. Thank you.